You're watching the Norfolk Southern Sherwood Subdivision. I'm Harold. Thanks for joining us. This video is about improving the performance of your rolling stock. We'll do several things to a sample boxcar that will show you how to make it run better and how to have fewer derailments. So if you're interested in that, or any of our other videos, please consider subscribing to this channel. Now, let's get on with the video. Before we go through the steps of the procedure, let's talk about when you should do it. I personally do this for every piece of rolling stock that I bring to my layout. But you say, I have hundreds of pieces of rolling stock. How could I possibly do that? And you're right, it's not realistic to do that on 100 pieces of rolling stock. But don't you have those pieces of rolling stock that derail when you don't want them to? They uncouple unexpectedly during an operating session. The cars wobble when you run them. Those are things that can be corrected by following the steps in this procedure. So maybe you select your biggest offenders and run them through these steps. And we'll start the steps right now. This is today's subject. Those of you with experience in the hobby may recognize it. That's right, it's an Athearn blue boxcar. They don't make these anymore, but I happen to have this one. It'll be suitable to demonstrate all the steps that we need to go through in order to improve the performance of our rolling stock. With our car assembled, we're now going to weigh it. I have it on the scale here. It's just a simple portion scale that you could find at Bed Bath & Beyond is where I got this one. We're going to follow NMRA recommended practice 20.1. In HO scale, a car should weigh 1 ounce plus half an ounce for each inch of length of the car. So we measure the car. It's approximately 5.5 inches long. If we do the conversion, we find that a car 5.5 inches long should weigh 3.75 ounces. Our car weighs 3 ounces. So to get to the ideal minimum weight that's called for in NMRA practice 20.1, we're going to have to add 3/4 of an ounce. And in a moment, we'll show you how to do that. The body of the car has been removed, and we're going to add 1 ounce of weight. That'll put us a little bit over. But remember, the recommended practice 20.1 is the recommended minimum weight. So if we go over by 1/4 of an ounce, that's going to be okay. What we're going to use is this item here. Steel weights from A-Line. They come in, if you look at the back, they come in 1/2 ounce sizes. So what we have is a piece of steel that's a 1/2 ounce. We're going to put 2 of these in here. They have a sticky back. What we're going to try to do is get them on the center line of the car equally spaced. There, that should be good enough. Now, of course, we realize that this is the easy part. The other kinds of cars that you might encounter where you have to add weight may be more difficult. For example, if you have a car like this, it's an intermodal well car, and it's too light, you would have to run it with containers in it, with containers containing weight. Good news is most well cars like this are die cast. They're metal, and therefore they do not require additional weight. If you have other such cars, for example covered hoppers, you might be able to remove the body. Well, I'll tell you one thing about that. These weights I had to remove from an Atlas covered hopper. And the reason is it was severely overweight, which is just as bad as being underweight. An overweight car can pull other cars of proper weight right off the tracks. So you want to go in both directions. Remove weight if it's overweight, add weight if it's underweight. If you have things like gondolas or other open top cars, you may have to run them with weights, or perhaps you can conceal these weights under the car, perhaps paint them so that they're not visible in the normal situation. In any case, we have now added the weight, and if we reweighed the cars, it would weigh 4 ounces, and our ideal minimum weight was 3.75 ounces. So that should be sufficient. We'll go on now to our next phase, where we're going to deal with the wheels and trucks. We see here the trucks as delivered, along with their wheels. One thing I noticed first of all about the wheels is they're plastic. Plastic wheels tend to accumulate dirt more easily than metal wheels. In my case, I always replace plastic wheels with metal wheels. So we'll do that right now. We will remove the wheels. That we had. Now we're left with the frames. And there are the frames. We have new wheels, so we should just put them on there, right? No, that's not right. Every manufacturer, no matter how precise they are, can make mistakes. So one of the things we want to do to eliminate derailments is make sure our wheels are engaged. To do that, we use this device. It's an NMRA standards gauge. I have our new metal wheel sets from KD. And when you replace wheels, remember, some cars have 33-inch wheels, some 36. So be careful. If you replace with the wrong size, you're going to end up with issues with coupler height. The way you use the gauge, take the wheels apart. If the wheels slip in there properly, as that one did, then they're in gauge. That one's good. That one's good. And that one's good. So we have good wheels. This now would be the point where you might consider painting the wheels and the side frames if you wish to do that. We could finish with what we just did. But instead, we're going to take one more step, and that's we're going to make the wheels more free rolling. In order to do that, we are going to use this little device. It's a truck tuner from Micromark. It's very easy to use. It's got one little sharp edge on here. What that's going to do is remount the ends where the bearings are for the points of the axles. And the way you use it is this. Just put it in there and give it a spin. Reverse the other side, put it in there, give it a spin. You want to press on that to make sure it's making good contact. Repeat that process for all 4 points where the wheels connect with the side frames. Once you're done with that, it's time to reassemble the wheels. So we do the opposite of what we did before. Take our wheel, put it in the side frame, and you can see they're pretty free rolling. That one just rolled away. And that's what we're looking for, minimum resistance. In this segment, we have now dealt with making the trucks more free rolling. The time has come to look at the couplers on our car. If we examine what the car came with, we find that we have plastic couplers. If that's what you want on your layout, fine, we don't have to do anything. We'll just go on to the next step, which is adjusting the coupler height. Many think that mixing coupler types on a particular layout can cause operational issues. So a lot of us standardize on a particular coupler, and the coupler manufacturer that we depend on is this one. KD Quality Products. They make a huge selection of couplers. And I'm sure they have something that will be suitable for whatever rolling stock or locomotives that you have. What I'm holding in my hand is the number 148. This is called a standard head metal whisker coupler, which is what we're going to use here. There are other kinds that could be used, and I'll show you those briefly. So, at least in my case, I'm going to standardize, and whenever I get a new piece of rolling stock, I'm going to replace whatever the couplers are with KD couplers. And it's not hard to do. case, you simply remove the little cover box, dump the coupler out of there. Do the same on the other end. As easily as they come off, and sometimes they come off easily and sometimes they do not, they're just as hard to put back on. Okay. So we've removed the couplers. There are two popular types of couplers that Katie makes. One is the one I showed you. It's this coupler here. It's a number 148 whisker coupler. It's got a standard shank and two little springs on either side that keep the coupler centered. And that's what we're going to use here. Before the 148 variety came to the marketplace, this is what we used. This is a Katie number 5 coupler. And the way you used it was, and the reason I have it was I have a huge supply. You take the metal spring, put it in here, put the coupler on top of it, and you're ready to go. It's a little more complicated than using the whisker coupler, so we're going to go ahead and use the whisker coupler. It's a relatively simple process. You take the whisker coupler and drop it. No, normally you don't drop it. You try not to drop it. Put it in the coupler pocket, making sure that the little springs are inside the box. And then you put the cover on. Now most covers in modern models are attached with screws. The old Ethern Blue Box, they're attached with these spring clips, you would call them. And they're hard to get on, so I'm going to have to take a second sort of off camera to get this connected correctly. But before doing that, we're going to do something else to improve the performance of our coupler. We're going to add some dry graphite. This comes in a kit that's made by Woodland Scenics. So I'll just squirt a little dry graphite in there. And if we get it all over the place, we can clean that up. Now I'm going to have to pick this up in order to put this on properly, so give me a moment. There, I've returned. Coupler's been inserted, and what you want to do is make sure that it's running freely. The only other thing to do at this point is the other end, which I will do when we're finished. And we'll go on to our next step, which is to make sure that the couplers have the proper height and clearance from the railhead. Having replaced the couplers, it's now time to check their height. This is very important. Mismatched coupler heights will cause operational problems. You'll see uncoupling when it's unexpected, and it's especially a problem when you're going up and down grades. Not only that, couplers whose heights are mismatched, they just look bad. So we want to make sure that all our couplers are of the correct height, and we're going to do that by using this device here. It's a KD coupler height gauge. It's metal, so don't use it on track that has power. What we do is we put the coupler height gauge where you see it, roll our car in, and what we're looking for is two things. We're looking for alignment of the coupler on our car with this part here, and we're looking for the trip pin on our coupler to not hit this shelf right here. So let's see how we do. Here comes our car. And I think you can see that's a pretty good match. We're not going to do much better than that. So that's one end. Here's the other end. Okay, so we see the same thing. We see the approximate alignment of the center of the couplers, and we see that the trip pin is not hitting the shelf. If the trip pin's too low, it will catch on turnout parts or other things in the track, and will cause derailments. So the good news here is this car is okay. In a moment I'll show you what we would do if it was not. If our coupler height was determined to be too low, which is the normal case, what we would do is we would add height by doing one of two things. KD makes these little fiber washers. They make two sizes, the gray one and the orange one. The orange one is thicker than the gray one. And what this is intended to do is to raise the body of the car from the trucks. And the way you use them is you take one of these little washers. That one ran away. I'll take this one. Put it over the hole where the bolster will go. Press it down into place. And then you would reinsert the truck. And the result of that would be the body of the car would be slightly higher, and that coupler that was low is likely to be a better match now. Wouldn't recommend you put more than 2 of those on. There are, of course, other cases. If the coupler is too high, what you're going to want to do is try to find a way to make the coupler lower, and that's going to be difficult. One way to do it would be to file off part of this bolster. And you can do that, but it's likely to damage something that you don't want to be damaged. Other solutions are, Katie has these for you. They have couplers like this one with offset shanks. In this case, maybe you can see in the picture, the shank of the coupler is actually at the top of the coupler head. So that would have the effect of lowering the coupler head itself so that it would match up with our coupler height gauge. It's not prototypical, but sometimes you have to do this. They also make a corresponding version that I don't have here where the shank is at the bottom. So those are some solutions when your coupler height does not match. In our case, of course, the couplers are fine, and therefore we are done with all the steps necessary to prepare this car for use on our land. That's the end of this video. We hope you enjoyed that, and we hope you employ these techniques on your railroad, and we hope it improves the performance of your rolling stock. So thank you very much for watching. If you have any comments or questions, please record them in the space below.